It's 8:30. All right, this is Dr. B here. It's Tuesday again, and I had a bunch of weird technical difficulties here, but it looks like everything is hopefully working right now. If you're in the chat there, it would be great to hear from you, see who's here tonight, different folks. It's always nice to see. There's a Pikachu Zaman's back, Rotex, awesome. Ritesh, good morning. It's actually night here. It's 8:30 at night, dark. So you must be on the other side of the world there, Ritesh. So this evening, what we're going to do is take a look at isotopes and ions, something that people seem to confuse a lot. And when you're under pressure on a test, you can kind of get messed up. So you want to really have this concept down. Hey, Andy, welcome. The other thing we'll do that I'd like to try is I've set up a Discord server, which I've actually never really used before talking to anybody. At the end of the chat, I'll share a guest link with you, and maybe we can try Discord and see if it's something that maybe works to extend the stream here. I see Jason's there, Danny's there. All right, India. Okay, Rotex, that makes sense then. You're on the other side, or kind of the other part of the world there. And Loretta is here from Texas. Excellent. Good to see you, Loretta. All right, so first, before we try this Discord server at the end, and I'll give you the link at the end of this here for that, we got to do some chemistry problems here. So let me jump over to this here, and I'll show you the problems, and then we'll do 6 or 7 problems for the next 20 minutes or so and see how that goes. All right, there it is. So these are the problems that I'd like to give a try. Hey, Caleb, you made it. Excellent. So we'll start off with the review problem and then do a bunch of stuff about isotopes. And then at the end, we'll try the Discord server out. See if that works. I don't know. It should work, but it was messing my mic up for my OBS studio and everything. So we'll see if it. I can't see you, Loretta. All I can do is just see chat. So it's very limited here with YouTube streaming. But I'm hoping later I'll give you guys a link you can just use in your browser that we may be able to see each other. I don't know. It'll be an interesting test. All right, so give this one a try. We did this last Tuesday there. Figure out the pH and the pOH for a 2 molar solution of HCl. And these are the equations we used. Caleb is from America. Yes, I am from just outside Washington, D.C. here, Caleb. So not too far. I'm in Maryland. All right. So let me see. Oops. So remember, HCl, that's a strong acid. That's a strong acid you should know. So you'll get these 2 ions here, H plus and Cl minus. So when we do this, the HCl is going to break apart into H plus and Cl minus. And since the whole thing's 2 molar, each one of these will be 2 molar. And all you need to do is put 2 in, because pH, that's the H plus right here. What is the negative log of 2? I'm going to have to type that in. So I end up with 0.30, but since we only have 2, let's call it that, and it's negative. So that's kind of interesting. Someone asked last week, can you have a negative pH? And you can have a negative pH. Jason, you got it. Yeah. So we actually can have a negative pH. Anything that's above 1 is going to give us a negative number. Be careful there, Ritesh. It's a negative. Don't forget about the negative. You could take the log, but you got to put your negative there. So if you wanted to find the pOH, now that we know the pH, how do you find the pOH? So we want to find, we're going to call it X. Rotax is asking, what is brine? It's just salt water, really. That's what I've always considered it to be, just NaCl aqueous. All right. So negative 0.3 plus X equals 14. So the pOH has to be, so we need to add negative 0, we need to add actually 0.3 to both sides. So these cancel out, and we end up with 14.3 as our whoops, what did I do? That's our pOH, isn't it? I may have just messed this all up. Yeah, I messed this up. So no, so that's right. So the pOH is 14.3. Wow. It's funny how having technical problems starts to consume part of your brain when you're thinking. And, you know, when you're taking tests and stuff, if you get caught up on maybe being late to the test or a technical problem, you don't think about it, but it actually consumes kind of part of your thinking, and it can really kind of mess you up. So as you're going to do your tests or things, or even studying, try to avoid any of those problems, like I had earlier this evening, for instance. So the pOH here, that is going to be 14.3. And that's kind of weird, right? We think pH is only from 1 to 14 or 0 to 14, but you can have pOHs that are above 14 there. And I guess you could have pOHs that are above, you could have this above 14 as well. All right, so let's move on, see if we can do better here. These are a little conceptually easier for my addled brain here tonight. Let me go over there. Hope I wasn't even on the thing. All right. So take a look. Which subatomic particle in isotopes differs? So they're all hydrogen, but what's different about them? And that's the key to isotopes. So this one has 1 proton, this one has 1 proton, and this one has 1 proton. So these isotopes all have 1 proton. The difference? You got it, Huang. That is the neutrons. So hydrogen, the most common form, doesn't have any neutrons, but it can have 1 neutron or 2 neutrons. That's about it. After that, it gets kind of unstable. So it really is, when we're talking about isotopes, all we're talking about is different numbers of neutrons. Same element, same properties. The chemical reactions are pretty much all the same too. Very slight differences. So let's try this. Let's actually go in here. Let me open up a new browser, and we'll try this here. So what are you seeing? That's what you're seeing. You're seeing my cat. Okay, that's fine. Here we go. So let's actually build the isotope here. It's telling me that you may be experiencing some buffering right now. So I'm not sure if the picture's gotten worse for you. And Jason, you're right. The atomic mass would be different too, because they have extra neutrons and those have weight. That's a good point. All right, so let's build those isotopes of hydrogen. 1 proton. Yeah, fine. The physical properties would be a bit different, but very, very little. More so for hydrogen because it's not very heavy starting out. Thank you, Xiao Mi. I appreciate that. So we have hydrogen. It's actually an ion right now because we have a positive charge. So let's stick a negative charge out there. Well, let's try. There we go. Now it's neutral. So what happens when we add 1 neutron? Put this up here. 1 neutron. The mass number goes up, but it's still hydrogen. Doesn't change anything. If we add another neutron, It's tritium. It's a little bit unstable. When there's nuclear reactors, they make some tritium, but it's still just considered to be hydrogen. So if you understand that and you have this visual picture here, that'll help you as you're doing your exams and such like that. And yeah, kind of interesting. If we add another electron, now it's a negative ion. And we don't see that a lot with negative ion. Ritish, you asked me how to focus long hours when studying. I think the biggest thing is breathing. You really just need to make sure that you're breathing right. You don't stop breathing while you're studying. People get stressed and then they don't keep breaths flowing in and out. That's my biggest hint. And only study for 20 minutes. Don't study for longer than 20 minutes. Always take a 2-minute break. Come back. That's my advice to you about studying. Let's go back and tritium. Yeah, it's kind of a nice sounding thing. And these are the only isotopes I think that have special names. I don't think any other ones do. All right. So here's the question, and you may already know this now. What is the difference between an isotope and an ion? That's kind of an important idea. So we remember the difference between isotopes, but what about ions? Let's take a look at this here. So here we have the trends for ionic charge, and I've shown you this a couple of times, but it's so useful. All of these form 1+ ions. All of these form 2+. These are positive, but they can have variable charge. We'll leave it alone. Kind of leave it alone. 3+, 3-, 2-, 1-, and 0. So all of these lose one electron. And both Jason and Andy are telling me that ions, the difference is with electrons. Absolutely. So here's sodium. It's neutral right now because the protons and the electrons, they're equal. It'll lose an electron to become an ion. But it's still sodium. There's no difference. It loses this shell here, so now it has an octet. It's positive. And chlorine got the electron, so it's negative, but now it has 8. And they're attracted to each other. We put brackets around it often, and they form an ionic bond, plus and minus. So ions are all about electrons. Isotopes are about neutrons. And that's the type of question that you'll get on exam, is they'll give you like a multiple choice where you have a lot of different answers, and you have to choose isotopes, neutrons, ions, electrons. That's pretty common. All right. Their electron configurations. Yeah, you could write the electron configurations from here, and ions would have different electron configurations, Caleb. You're absolutely right. Like they'd have one less electron, or over here, one more. All right. NB says, hello. Hello. Yeah, Jason, so in ionic bonds, it is a transfer, but when we talk about ionic and covalent, it's kind of like, you think of ionic and covalent kind of as being ionic character or covalent character. So some things are kind of a little bit more ionic than others. And then you have some right in the middle that are kind of hard to tell. So chemistry is always like that with the exceptions. All right, let's do, yeah, I like number 4 because I didn't know this until I was in college, unfortunately, in university, why neutrons are important. I'm wondering if anybody has any idea. And Jason, you're right. Covalent shares electrons, but polar covalent, which is getting closer to ionic, doesn't share them equally. Yeah, I'm going to agree with you about the directionality. Nuanced, yes. That's a good word, Jason. I like nuanced. So, why are they important? Let's go back and look at hydrogen again. See how it's jumping around? So in this case, let's make another element. I'm going to add some protons. 3 is lithium, atomic number 4 is beryllium. How about 5? And you can see with boron, for instance, what's happening. it's unstable. We need to somehow kind of stabilize all those positive charges pushing together or pushing against each other, because like charges, they repel. So neutrons, they kind of stabilize. If you get the right number of them, they make that nucleus stable. So they're stabilizing the nucleus. And like Jason said earlier, they do add to the mass of the nucleus. And sometimes you can have different numbers that are stable. Too many, it doesn't work, but there's kind of a magic number of them. It's not always equal to the number of protons, but it's close usually. And that's what gives us our stability. So if you don't have, oops, I made beryllium. If you don't have enough neutrons, you don't have a stable element. As chemists, we don't really mess with neutrons because we don't get in there and change the nucleus. Chemists are all about the electrons. Let's make this neutral here. There we go. That feels better. All right. Let's go back and we'll look at one kind of hard problem here, and then where are we at? Yeah, maybe we'll jump over a little bit after that. Maybe another problem after this. Try that Discord server. See if we can figure that out. All right. Take a second and read that. Try to figure out what's being asked. All right. So we have boron, and we've been given some information. And when you see this number here, this is the mass number. Call this the mass number. And it's the number of protons and neutrons. So if we look at it, about 20% has what must be 5 plus 5 is 10, so 5 protons and 5 neutrons. But here we have 5 protons and 6 neutrons. But they're not like 50-50. They're different. So to figure out where this number came from, we take and multiply this by the decimal, really. We're going to take 19.9% of 10, and we'll take 80.1% of 11. So really what you do is you take this over 100 to get your decimal, and then you multiply. So that would be 0.199 times 10, which is 1.99. And then 80.1 times 11, 8.81. And when you add these together, I get 10 point, let's call it 8. 10.8. So by figuring out these numbers here, right? And Jason, you've got it down there with the math. And Wang, I would say, yeah, you've got, should be 11 times 0.80. Yeah, it's a weighted average. That's a good way to think of it. So that's where this number comes from. It's because with boron, some of them only have 5 neutrons, some have 6. So this number is an average of the isotopes. That's the thing I really want you to understand. This is an average, a weighted average of the isotopes. So let's see what that looks like in this app here. And I should put the links to this app in the description. I'll do that afterwards. These are really cool apps. Where are we at? Here we are. And you can always go to this phet.colorado.edu and see all of their stuff. So I'm going to go to the mixtures here, and here's boron. So if you think about it, the green ones are the ones that were the 80%. What was that? Boron 11. The purple, that was the 19.9%. So this is just like the mixture. If you grabbed a sample of boron out of the earth or a lab, this would be the mixture for that. So Xander, electron and geometry, molecular geometry are different. If you search on that, you'll find an awesome video I did just on that topic. So Google would be, I think it comes up first in Google or pretty close, but they are different. All right. So hopefully you understand a little bit. So like carbon, for instance, carbon is mostly carbon 12 with some carbon 13 and very little carbon 14. So its average mass will be closer to 12. It turns out it's 12.01. So it's very close. So play around with this app if you have a chance. This is the address. I'll make it large. I'll go back here and make it really large so you can see it. Because otherwise you'll forget and you won't go to the description. Nobody goes to the description. Let's make it 144. So these are where I'm getting the apps I'm using this evening. And if you spend time with these, it will help your test scores because you'll just have a real good understanding of, you almost feel what things are like by using this app and really see them. So Jason, that's a hard question. Do any elements not have isotopes? So some only have the same number of protons and neutrons. They don't vary. But an isotope, I guess, is any element is an isotope. So I guess I would say all elements have one isotope. Some have only one isotope. I hope that makes sense. It's kind of just terminology. But not all elements have multiple isotopes. So how about this? Can an isotope be an ion? That's another great question. I like that question. I would put that question on my test. I think I have put those on my test in the past. But I made them write the answer. It wasn't like yes, no. Can an isotope be an ion? Why don't we do this? Why don't we go back to our app and see if we can make an isotope or an ion that is an isotope, or vice versa, or some combination. And this is all free. This app costs nothing to use, so it's all free. All right. And Huang, yes, if it loses, that would work. All right, let's do it. So let's make just hydrogen. That's easy. So it's positive. And yeah, so we can have an isotope. We had started with protium right here. Here's, oops, I just have neutrons. I don't think you can really do that. So you have protium, that's an ion, deuterium, and tritium. So absolutely. And this app, Caleb, the way to get this app, this is called Build an Atom. So yeah, thanks Wesley, it's the PHET simulator. So if you just type in PHET, Build an Atom, it'll come right up. And it's really cool. I've used this with my students for a long time, and it's interesting to watch how you teach them the theory and you do it on paper, but when they see the moving the atoms and the particles around, it really kind of clicks for them, especially molecular geometry. The molecular geometry is really good on here. Xander, you were asking about that. It'll show you molecular geometry and electron geometry. So that one is really, really good. Let's see if we can find it. PHET, molecular shapes. Yeah, so there it is. It comes right up. So you can use this one too. I don't know. I think it's available on an iOS because it's HTML5, so it should work on everything. So you can like add, things here. You can stick an electron cloud on there. I don't even know what that geometry is. Tetrahedral electron, molecular is trigonal parameter. So it shows you all that stuff down there. See it without my big head in the way. Yeah. All right, so I think we're going to wrap up. What I'm going to do right now is I'm going to try to go over and get my Discord server a link to put in the chat for the Discord server just to see if this works. If it's a miserable failure, that's great. We'll talk about it next time we meet on Tuesday, but it'd be kind of cool to try it. So how do I do that? I think I just go over here in my browser And it was killing me tonight because it wouldn't access my microphone and all that, but I think I got it figured out. All right, Discord. How many people use Discord? We did get over, Jason, 20 people in the chat. The record people in the chat is 26, and we actually have on my thing 25. So we are close to the record here. So that's kind of exciting. All right, I'm going to go to my community hangout and create an invite, and it says it'll expire in 7 days. That's okay. And I'm going to put it in here, but I'm going to have to get off of the streaming because it conflicts with my camera and weird stuff happens. So yeah, and Caleb, enjoy that. You can spend a lot of time with it. All right, so I'm going to end the stream, and then I'm going to go over to Discord. And Huang, I've used Discord for like generating images and stuff, but I've never actually talked to anybody on Discord before. So I'm kind of excited about that. I think there's some good things for education-wise that it can do. So, all right. Yep, 25 people, Obs. That is kind of exciting. All right, so I'm going to end the chat. Oh, let me send this. There's the link in Discord, and I'm going to head over there, and maybe I'll see some folks there. Yeah, Caleb, I don't know how it works either, so we're in this together. Okay. Oh, somebody is already here, which is pretty cool. Yep. Take care, Wesley and Huang. All right. If this doesn't work on Discord, I'll see you guys Tuesday at 8:30 again out here Eastern Standard Time. This is Dr. B, and as always, thanks for watching. Have a good one, Caleb. I'm out of here. Choo.